morning friends. In mechanical properties of fluid, we are going to start our discussion about the Stokes law. Already we discussed about the laminar flow. In laminar flow, the different layers of a fluid are slide over each other instead of the entire fluid is flowing with the same velocity. That means in laminar flow, the different layers of the fluid flowing with the different velocity. As we going from bottom to the top, the velocity of the different layer is increases. So as a result, the resistive force exerted between the two consecutive layers at the surface of contact of these two layers, and hence the relative motion take place between the two layers. On the base of this, we are going to discuss about the Stokes law. Stokes observed that when a small spherical solid body is moving in a viscous medium with velocity v, the medium has the coefficient of viscosity is eta. At that time, the viscous force or the resistive force act on a body is F of v is equal to 6 pi eta RV or the nRV. N is the coefficient of viscosity of a given fluid. R is the radius of a spherical solid body, and V is the velocity of a body in a viscous medium. It means whatever the resistive force act, that means the viscous force act on a body, is directly proportional to the velocity of this body. Right? So this statement is known as the Stokes law. Again, when a small spherical solid body moving in a viscous medium of coefficient of viscosity N, the viscous force acting on a body is 6 pi eta RV. So this statement is known as the Stokes law. So this question is most important. The entire question is asked that Stokes law and obtain equation of terminal velocity of a body, that can be asked for the 4 marks question. And if this question is asked in 2 marks, at that time this question is divided in 2 parts. First part is that Stokes law and obtain equation of motion of a body. That means equation of motion, that means the resultant force act on a body during the motion of a body in viscous medium. Why this resultant force is known as the equation of motion? Because according to the Newton's law, a body moving according to the resultant force act on it, and according to the second law, F is equal to ma. F is the resultant force. So here we have to calculate the resultant force act on a body. According to this resultant force, this body is moving in a viscous medium. Clear? Okay. So first we are going to write down the Stokes law. So Stokes law is that the statement when a small spherical solid body of radius r moving with speed v in a viscous medium having coefficient of viscosity and the viscous force on a body is Fv is equal to V for the viscous, F for the force, is equal to 6 pi nR. This statement is known as the Stokes law. This statement is known as Stokes' law. Again, the statement is that when a small spherical solid body of radius r moving with speed v in a viscous medium having coefficient of viscosity n, the viscous force on a body is F3 is equal to 6 pi n RV. This statement is known as the Stokes' law. Statement is quite lengthy but very easy. Keep in mind this figure so we can easily understand when a small spherical solid body of radius r moving with speed v in a viscous medium having the coefficient of viscosity n, the viscous force act on a body is F of v is equal to 6 pi eta RV. Directly we have to accept this equation of resistive force or the viscous force act on a body without any proof. Now, first we are going to write down the answer of this question. What are the resultant force act on a body? Right. For that purpose, as shown in the figure, consider a small spherical solid body of radius r and density is rho. Moving with velocity v in a viscous medium, having the density is sigma. Here the density of the fluid is, we consider the sigma, while the density of material of a body is rho. For that purpose, as shown in figure, consider a small spherical solid body of radius r and density rho, moving with speed v in a viscous medium having coefficient of viscosity and density sigma. Density sigma. Right. Now the forces act on a body. The forces act on a body are here the three forces act. First is the weight. Weight is equal to mg. M is the mass of a body and g is the gravitational acceleration. Here the mass of a body is not given, but the radius is given and body is the spherical. Therefore, volume into density represent the mass. So first is the weight. That is the F1. F1 is equal to mg. This force act in downward direction. Now mass is equal to volume into density into g. Therefore F1 is equal to volume of a body 4 by 3 pi r cube. Density is 0 into g. That is equation number 1. That is the weight of a body acting in vertical downward direction. Now second is the buoyant force. That is the F. Now what is the buoyant force? Buoyant force F2 is equal to m0g. That is act in vertically upward direction. Okay. Now what is the buoyant force? When the body is immersed in a fluid like water or the liquid, at that time what's happened? Consider a container completely filled with a liquid. As we immerse the body So body only can immerse in this liquid if and only if this body is able to displace the molecule of a fluid equal to the volume of a body. So when this body is immersed in this liquid, like this, at that time this volume of a molecule or the molecule of this volume of a fluid are displaced. This displaced molecule apply the force on a body which opposes the body in a fluid. And this force is known as the buoyant force. That is known as the buoyant force. Buoyant force is equal to mass into gravitational acceleration. But here mass is the displaced molecule of a fluid. Displaced molecule of a fluid. Therefore, volume into density into G. Now, volume of a displaced molecule of a fluid is equal to the volume of a body. That means there is the 4 by 3 pi I cube. Now here, we have to take the mass of a fluid, therefore the here density of the fluid is required, not the density of material of a body. Therefore, volume of a body into density of a fluid, that is the sigma into G. Therefore, buoyant force F2 is equal to 4 by 3 pi I cube sigma G. Again, what is the buoyant force? When the body is immersed in a fluid like a liquid, at that time, to immerse the body in a fluid, it has to displace the molecule of a fluid equal to the volume of a body. So what are the fluid molecule are displaced? They oppose, or this molecule oppose the immersing of a body in a fluid. Therefore, the buoyant force is act on a body. Buoyant force is equal to mgg. Mg is the mass of the displaced molecule. Mass of the displaced molecule. So is equal to the volume of a body, or the volume of a displaced molecule is equal to the volume of a body into density of a fluid into G. Therefore, 4 by 3 pi I cube sigma G. So here M0 is equal to mass of displaced molecule of fluid is equal to volume of the body into density of a fluid. Therefore, M0 is equal to F2 is equal to M0. That means the volume of the body into density of a fluid into G. Therefore, 4 by 3 pi I cube sigma into G. That is in upward direction. That is the equation number 2. So that is the important thing. To write the equation of the buoyant force. Right? Okay. Again, the buoyant force is equal to mgg, where the mg is the mass of the displaced molecule of fluid, is equal to volume of body into density of a fluid. We are using this concept to write the equation of F2. F2 is equal to volume of a body into density of a fluid into G. Volume of a body is 4 by 3 pi I cube. Density of a fluid is sigma, already we mentioned here, into G. So this force acts in vertically upward direction. And third is, and from Stokes' law, Third is the viscous force. Fv is equal to 6 pi nRv. That is in opposite direction of motion of the body. Therefore, here the body is falling in fluid, that means moving in downward. Therefore, the viscous force act in vertically upward direction. That is the equation number 3. So, when the body is moving in a fluid, the three forces act. One is the weight, F1 is 4 by 3 pi r cube rho into g in upward direction, in downward direction. While the second is the B1 force, mgog is equal to 4 by 3 pi r cube rho into g. That is vertically upward direction. And from Stokes' law, third force is the viscous force F of V or the Fv is equal to 6 pi in Rv in vertically upward direction. Therefore, total force or the resultant force on a body is Fr is equal to F1 in downward direction, therefore we take the positive. While the F2 in upward direction, we consider negative. Fv also in upward direction, we consider negative. Substitute the value, therefore 4 by 3 pi r cube rho g. That is the value of F1. Now F2, 4 by 3 pi r cube sigma g minus F3 6 pi eta rv. 6 pi n r. From first step, we take the common 4 by 3 pi r cube and g. Therefore, resultant force Fr is equal to 4 by 3 pi r cube common. Here remaining is rho minus sigma into g. And last term as it is 6 pi eta rv. That is our equation number 4. Equation 4 is the equation of resultant force act on a body when it moving in a viscous medium with the velocity v. Right? So equation 3 is the resultant force act on a body, and that is known as the equation of motion of a body. Equation 3 is the equation of resultant force act on a body. It is also known as equation of motion. Equation of motion of the body. Because why that is known as the equation of motion? Because according to the Newton's law, so the any body can be moved according to the resultant force act on a body. So here the resultant force act on a body is Fr is equal to 4 by 3 pi r cube rho minus sigma into g minus 6 pi eta rv. So according to that, the body perform the motion in a given viscous medium. Clear this? So there is the 2 marks question. First, the statement of the Stokes' law, and then mention the forces act on a body and obtain the equation of the resultant force. Very easy answer this question. Now the second question for 2 marks is obtain the equation of initial acceleration. Obtain the equation of initial acceleration. So question is that the resultant force act on a body moving in viscous medium and obtain the equation of its initial acceleration. Equation of initial acceleration. Initial acceleration is our a0. So how we obtain it? So initially at time t is equal to 0, the body not just started the motion. At that time its initial velocity is 0. And when it starts its motion, so its velocity start from 0 to going to increase. Therefore the acceleration motion take place. For that purpose, as we assume that suppose the initial acceleration of a body is a0 and at this time the velocity is 0. Velocity is 0. Therefore the resultant force Fr is equal to mass from Newton's second law, Fr is equal to m into a0. M into a0. So for that purpose, suppose initial acceleration of a body is a0 and initial velocity is v is equal to 0. Therefore, the resultant force Fr is equal to m into a0 from Newton's second law of motion. The resultant force Fr is equal to m a0 from Newton's second law. Now we know that what is the mass of the body. Already we discussed here 4 by 3 pi r cube rho. Therefore 4 by 3 pi r cube rho is the mass into a0. That is our resultant force. That is equation number 5. So now the body moves in a viscous medium according to this acceleration and according to this resultant force. Now substitute this value of Fr in equation 4. Substitute equation 5 and v is equal to 0 in equation 4. In equation 4. Why we substitute the v is equal to 0? Because the initially, that means at time t is equal to 0, the velocity of a body is 0. Velocity of a body is 0, so according to the Stokes law, velocity is 0, therefore the viscous force will not start to act on a body. Therefore the F3 is also 0. Only the F1 and F2. Therefore we can add 4 by 3 pi r cube rho is 0. That is the value of Fr is equal to 4 by 3 pi r cube rho minus sigma into g. And this last term is 0 because the v is equal to 0. We require the a0. Here 4 by 3 pi r cube cancel. Therefore a0 is equal to rho minus sigma into g upon rho. Rho minus sigma g upon rho is the equation of initial acceleration of a body in a viscous medium. Is the equation of initial acceleration of a body. So sometimes the 2 marks question will also ask like this way. That the equation of the resultant force act on a body and obtain the equation of initial acceleration of a body. Clear? After that, we are interested to obtain the equation of terminal velocity. Before that, first we revise it again. What is the Stokes law? When a small solid spherical when a small spherical solid body of radius r moving with speed v in a viscous medium having coefficient of viscosity n, the viscous force on a body is Fv is equal to 6 pi n Rv. So this statement is known as the Stokes law. Now, our question is that we have to add the Stokes law and obtain the equation of motion or the resultant force act on a body. As shown in figure, consider a small spherical solid body of radius r and density u, moving with speed v in a viscous medium having coefficient of viscosity n and the density sigma. The forces act on a body are, first is the weight F1. Weight force is equal to mass into gravitational acceleration. But here mass not given, therefore volume into density into g. Volume of a spherical body 4 by 3 pi r cube, density is rho into g. This force act in downward direction, therefore the downward arrow. While the second, buoyant force, as the body immersed in a fluid. So fluid molecules which are displaced due to the immersing of a body oppose the immersing of a body. Therefore, that is this force is buoyant force is in vertically upward direction. And buoyant force is also mgog. Mgo is the mass of the displaced molecule of a fluid. Is equal to volume of the displaced molecule. Volume of a displaced molecule is equal to the volume of a body into density of a fluid. That is the mass. Therefore, F2 is equal to volume of a body into density of a fluid into g. Volume of a body is 4 by 3 pi r cube. Density of a fluid is sigma into gravitational acceleration g. Now from Stokes law, third force is the viscous force. F3 is equal to 6 pi eta Rv. That is the resistive force act in opposite direction of motion of a body. Therefore, we consider that is also in vertical upward direction. Therefore, the total or the resultant force act on a body is Fr is equal to F1 minus F2 minus F3. Here we consider the downward force is positive while the upward directional forces are negative. So downward force 4 by 3 pi r cube rho g. Upward directional force, buoyant force 4 by 3 pi r cube sigma g. And the viscous force minus 6 pi eta r. So from first two term we take the common 4 by 3 pi r cube and g. Therefore, 4 by 3 pi r cube into rho minus sigma into g. Last term as it is 6 pi in Rv. So, equation 4 is the resultant force act on a body. Resultant force act on a body. And it is also known as the equation of motion of a body. Right? Now the next question, that this equation of resultant force act on a body, and here the equation of the initial acceleration. So initial acceleration, that means at time t is equal to 0. The velocity of a body is 0 here. At time t is equal to 0. Velocity is 0, acceleration is 0. Acceleration is a0. So suppose the initial acceleration of a body is a0 and initial velocity is v is equal to 0. Therefore, the resultant force from Newton's second law, Fi is equal to ma0. ma0. Now, m is the mass of a body, 4 by 3 pi r cube rho into a0. That is equation number 5. Substitute in equation 4. Substitute in equation 4. And also we substitute the v is equal to 0. Therefore, substitute equation 5, Fi is equal to 4 by 3 pi r cube rho. And V is equal to 0. Therefore, this equation becomes 4 by 3 pi r cube A0 is equal to 4 by 3 pi r cube rho minus sigma into G. Here V is equal to 0, therefore this term is 0. 4 by 3 pi r cube is cancelled from both sides, therefore only initial acceleration A0 is equal to rho minus sigma into G upon rho is the equation of initial acceleration. Right? Okay. So there is the initial acceleration of a body. Now what's happened? As the time increases, so the velocity of a body is increased. Velocity of a body is increased at the time, the f of v, that means the viscous force is also increased. So in short, downward force is weight force, that is the fixed, that is independent of motion. Buoyant force is also fixed value force, that is not depends on the speed. Okay. Only the viscous force depends on the speed of a body. Therefore, as the time passes, so what's happened? The viscous force increases, velocity increases, therefore the viscous force is also increased. Now, at one time, any instant of time, when the downward force and upward force becomes the same, that means F1 is equal to F2 plus F of V. At that time, the acceleration of a body is 0. It means the body moves in a fluid with a constant velocity. And this velocity is known as terminal velocity of a body. Clear this? So we are interested to obtain this equation, Now the terminal velocity of a body. So we are interested to obtain the equation of terminal velocity of a body. For that purpose, we are trying to this way. As the time passes, the velocity of a body increases, and hence the viscous force act on a body also increases. So as a result, the resultant force Fr, or resultant equation of the force is this, and Fv is equal to 6 pi n Rv. Velocity increases, Fv increases. Therefore, the Fv is increases. So as a result, the resultant force is decreases. Right? That means the upward directional force is increased. Suppose at time t is equal to t, the downward directional force is same as the upward directional force. In that case, the resultant force becomes the 0. No force act on a body. Therefore, the velocity of a body is remain constant. After this situation, the velocity of a body becomes the constant, and that is known as the terminal velocity. So we are going to enter this. So as the time passes, the velocity of a body or the speed of a body increases with the increase, and hence viscous force of a body increase. Thus, the resultant force Fr decreases. Fr decreases. Suppose at time t, we assume that suppose at time t, downward directional force F1 is same as the addition of upward directional force. the resultant force becomes 0. Resultant force Fr becomes 0. And hence velocity becomes constant. And hence velocity of a body is constant. This velocity is known as terminal or final velocity of a body. Final velocity Vt of a body. To obtain the equation of the terminal velocity in our equation 4, what is our equation 4? 4 by 3 pi r cube rho minus sigma into g minus 6 pi eta rv. Right? Here we substitute the Fi is equal to 0 and V is equal to V. Therefore, substitute V is equal to Vt and Fi is equal to 0. Resultant force is 0. In equation 4. Equation 4 is this: 0 is equal to 4 by 3 pi r cube rho minus sigma into g minus 6 pi n r. Instead of the V, we can add the Vt. We are interested to obtain the equation of velocity Vt. Therefore, taking this side, it becomes the positive 6 pi n I Vt is equal to 4 by 3 pi r cube rho minus sigma into g. Now listen, 1 times r cancel, so here the square is remaining. Pi cancel. Then 6 here, so 2 3 are 6. So these 2 is cancelled here. So we can add like this way. Therefore the Vt is equal to 4 by 3 r square g into rho minus sigma upon, from this side 6n. So here 2 cancel. So 3 is remaining. Therefore 2 by 9 r square g upon n into rho minus sigma is the equation of terminal velocity of a body. Is the equation of terminal velocity of the body. So here, to obtain the equation of the terminal velocity of a body, so this part is important. As the time passes, so what's happened? Due to the downward directional motion, the velocity of a body is increases because there is the accelerated motion. As the velocity increases, so viscous force Fv is equal to 6 pi n Rv also increases because this force is the velocity dependent force. Now the one situation is that means at any time t, the situation arises is that the downward directional force and upward directional force becomes the same. So this force and this force becomes the equal. Therefore the resultant force becomes the 0. When the resultant force becomes 0, according to the first law, Newton's first law, so velocity of a body becomes the constant. Right? And this velocity is known as the terminal velocity or the final velocity. To obtain the equation of the final velocity, we substitute the V is equal to Vt and Fi is equal to 0 in our equation of the resultant force. Therefore, 0 is equal to 4 by 3 pi r cube rho minus sigma into g minus 6 pi r n r Vt. Take this term in this side, therefore positive 6 pi n r Vt is equal to 4 by 3 pi R cube rho minus sigma up into G. Here I cancel, pi cancel, only Vt is equal to 4 by 3 R square rho minus sigma into G upon this n and sigma. So here we cancel this, therefore 2 by 9 R square G upon n rho minus sigma is the equation of terminal velocity. So very easy, we have to add up the 1 or 2 times so we can easily understand this thing. Clear this? So sometimes the 2 marks question up to the derive the equation of the resultant force, and sometimes the 2 marks question is also asked. Write the equation of the resultant force act on a body and obtain the equation of the initial acceleration and also the terminal velocity of the body. But combine the entire answer of the question, write the Stokes' law and obtain the equation of the terminal velocity. That is a 4 marks question. That is the most important from this chapter. Earlier is the Bernoulli's equation, next is this. Clear? Okay.